Okay, in this video, we're going to discuss prisms and pyramids and kind of their connection. So you've learned in the course content that the volume of a pyramid is always 1/3 the volume of a prism with the same height and base. And that's the same relationship for cones and cylinders. A cone's volume is always 1/3 of the volume of a cylinder that's got the same radius and the same height. I'm kind of going to show you some intuition about why that is, or maybe a little visualization, using some software called Tinkercad, which allows us to kind of look at how 3D shapes work. So I've got a prism here, and I can show you that it's 20 by 20 by 20. And then I've made six congruent, or six pyramids that are all the same size. So you notice it's 20 by 20 on the base, so same base as the prism, but the height is only half as much. And I've cloned it 6 times and just kind of rotated it. So I want to show you I'm going to be able to fit these six pyramids into this prism that is twice as high, but has the same base. So why don't we start by taking this guy, and we'll place it right over it. So now I've got a little hourglass, and I'm going to do the same thing. I'm going to bring all six of these prisms at all of the exact same size. So I'll bring that one together. We'll rotate and take a look at it in a second. So now here's my fourth pyramid, and I'm going to bring this one in. You can kind of see where it's going to this side here. So now if I rotate just quickly, I'm not sure if I put these together exactly correctly. Nope. So I'm building the same prism. Let's bring that one in. I've now got most of my cube put together. I've just got two more. So you can notice that there are going to be exactly six prisms, six pyramids fitting into the exact same shape and size as this prism that is twice the height. So there I have it. There's my box. I haven't exactly put it together correctly, but there we go. I've got the exact same shape as the box. So I notice that six pyramids with half the height are going to equal the same volume as a prism. So that means if I reduce the height of this, so it's the same height as the pyramid, then it's only going to fit the equivalent of 3 pyramids worth of volume. So that's one way to kind of visualize. I know it's hard from home. If we were in class, we could maybe fill pyramids with water and pour them into a prism. But if 6 pyramids of half height fit into the prism, then if I cut the prism in half, the equivalent of 3 pyramids will fit. So that's one way to think about why 3 pyramids will fit into a prism with the same base and height. Why is this true for cones and cylinders as well? Well, let me take a pyramid and I'll put it onto my grid. A cone is just a pyramid where my base is infinite size. So here's a square-based pyramid. 4 sides. There's a pentagonal pyramid, so the base is 5 sides. You notice that if I change the number of sides as it approaches infinity, so right now this is a 28-sided pyramid, it looks basically like a cone. So the reason cones and cylinders are the same as pyramids and prisms, you can imagine a cone or a cylinder as just a prism or a pyramid with infinite sides. Another way to visualize this same thing is to take a look. Here there are 3 pyramids put together to make a prism. This one's a little bit harder for me to visualize, but I can take them and I can separate them, if that helps. We can look at these pyramids. These pyramids have been manipulated a little bit, so the point isn't exactly in the center, but the triangles are all the same size. You can kind of see it there as well. This is why pyramids are always 1/3 of the equivalent prism. So if I'm ever solving a volume of a pyramid question, if I've got a square-based pyramid, and the base is, let's say, 3 meters by 5 meters, so not quite the Great Pyramids. And I've got a height of 4 meters. This is a square-based pyramid. So my volume is going to be the area of the base, 3 times 5, times the height, and then we're going to divide by 3. So I prefer to have a divide by 3 to the fraction. You could also write it as 1/3 times the volume of that equivalent prism, which would be 3 times 5 times 4. And the same thing would work for a cone. The volume of a cylinder, we know, is just the base, pi r squared, times the height. So to turn that cylinder into a cone, it's always exactly 1/3, or we divide what we get by 3. So that's a little bit of, hopefully, a helpful visualization on the relationship between pyramids and prisms and between cones and cylinders. The other part of this lesson was we were finding surface areas of these same shapes. So I've got a cone and a pyramid. If I want to find the surface area, that means I need to find the area of all the sides. So I need to find the area of the base and then the area of the 4 triangles. So I can take a look at this pyramid and I know, okay, well, the base is 20 by 20. That's fine. The height is 15. That height we can't use directly to help us find the area of these triangles. So the area of the triangle is going to be the base times the height of the triangle, which is not the same as the height of the pyramid. So we call the height of that triangle the slant height. You can tell it's a little bit longer than the height of the pyramid because it's on an angle going from the base to the tip. But I need that slant height to find the area of each of these side triangles. So the way we're going to do that is through Pythagoras. If I know the height of the pyramid and I know the base, I can take a little triangular slice. So I'm going to show you that here. Hopefully the visualization helps. I can make a little right triangle slice. So you can see that's a right triangle where I've got half the length of the base as one leg. The height of the triangle is one leg. And then my hypotenuse will be my slant height. So we can use the Pythagorean theorem to find the slant height, and then we can use that to figure out, okay, what's the area of the triangle. So that's just a little visualization to hope you see why slant height is different than the height of the three-dimensional shape and how we can find it with the Pythagorean theorem. It's the exact same thing with a cone. To find the surface area of the cone, I again need the slant height, which is not the same as the height of the cone. You can see it's a little bit longer, right? The cone height is just a direct straight line drop from the tip to the center of the base. But the slant height is again part of this triangular slice. I'm going to show you again that triangular slice. It's a right triangle, and it's a right triangle where the right angle is right at the center of the base. So I've got the radius of the cone is one leg now. The height of the cone is the second leg, and then I can solve for the slant height, which is the hypotenuse. So again, when we're finding the slant height, which we need to find the surface area of a cone or a pyramid, you're going to need to use your knowledge of the Pythagorean theorem, and you remember that you're kind of taking a right triangle slice out of your cone or your prism to calculate that. So I hope that 3D visualization helps a little bit. And again, let me know if you have any questions when you're working with the volume and surface area of cones and pyramids. Okay, thanks for watching. That's all for now.